Are astronomers wrong about dark energy? New study casts doubt on universe's accelerating expansion. The universe's expansion might not be accelerating, but slowing down, a new study suggests. If confirmed, the finding would upend decades of established astronomical assumptions and rewrite our understanding of dark energy, the elusive force that counters the inward pull of gravity in our universe. Two separate teams of astronomers, while observing bright, exploding stars called Type 1a supernovas, put forth the idea in 1998 that dark energy might enable the universe to expand at an accelerating rate. The scientists had noted that some of the most distant supernovas were dimmer than expected and concluded that they had moved away from Earth faster than anticipated. The discovery won them a Nobel Prize in Physics in 2011. However, the nature of dark energy has remained a mystery, and its role in the universe's expansion has been called into question before. Last year, a consortium of hundreds of researchers, using data from the Dark Energy Spectroscopic Instrument in Arizona, developed the largest ever 3D map of the universe. The observations hinted at the fact that dark energy may be weakening over time, indicating that the universe's rate of expansion could eventually slow. Now, a study published November 6th in the journal Monthly Notices of the Royal Astronomical Society provides further evidence that dark energy might not be pushing on the universe with the same strength it used to. Young-wook Lee, a professor of astrophysics at Yonsei University in South Korea and lead researcher for the new study, said that the project's findings last year represented a major paradigm change, and our result, in some sense, agrees well with that. Lee and his colleagues' work builds on the evolving understanding of dark energy, suggesting that the universe's expansion has already started to slow down, something that could alter the fate of the universe itself. Dark energy is there, but the present universe has already entered a decelerating phase today. So the fate of the universe could change, and if you can change the fate of the universe, that is really important progress in cosmology. To reach their conclusions, the researchers analyzed a sample of 300 galaxies containing Type 1a supernovas and posited that the dimming of distant exploding stars was not only due to their moving farther away from Earth, but also due to the progenitor star's age. Study co-author Junhyuk San, a doctoral candidate of astronomy at Yonsei University in South Korea, said that before our work, Type 1a supernovas were thought to explode with nearly identical intrinsic brightness, making them highly reliable standard candles. However, we found that their luminosity actually depends on the age of the stars that produce them. Younger progenitors yield slightly dimmer supernovas, while older ones are brighter. The team has a high statistical confidence, 99.99%, about this age-brightness relation, allowing them to use Type 1a supernovas more accurately than before to assess the universe's expansion. If confirmed, this would represent the most significant shift in cosmology since the discovery of dark energy in 1998. It would suggest that the expansion of the universe is no longer accelerating today, and that dark energy is not a constant force, but something that evolves over time. This discovery would open an entirely new chapter in our understanding of the physical nature of dark energy, how it has changed throughout cosmic history, and what it ultimately means for the fate of the universe. Eventually, if the expansion continues to slow down, the universe could begin to contract, ending in what astronomers imagine may be the opposite of the Big Bang, the Big Crunch. That is certainly a possibility. Even 2 years ago, the Big Crunch was out of the question. But we need more work to see whether it could actually happen. The new research proposes a radical revision of accepted knowledge, so, understandably, it is being met with skepticism. Adam Rees, a professor of physics and astronomy at the Johns Hopkins University, and one of the recipients of the 2011 Nobel Prize in Physics, said that this study rests on a flawed premise. It suggests supernovae have aged with the universe, yet observations show the opposite. Today's supernovae occur where young stars form. The same idea was proposed years ago and refuted then, and there appears to be nothing new in this version. However, Lee said Rees's claim is incorrect. Even in the present-day universe, Type 1a supernovae are found just as frequently in old, quiescent elliptical galaxies as in young, star-forming ones, which clearly shows that this comment is mistaken. The so-called paper that refuted our earlier result relied on deeply flawed data with enormous uncertainties. The age-brightness correlation has been independently confirmed by two separate teams in the United States and China. Other experts in the field, who were not involved with the study, echoed some of Rees's concerns. Dan Skalnick, an associate professor of physics at Duke University in Durham, North Carolina, noted that the study makes a leap from host galaxy age to supernova age that isn't physically justified. The authors are proposing ideas that the community has already tested and corrected for with much larger data sets. The universe is still accelerating just fine. Dylan Brout, an assistant professor in the departments of astronomy and physics of Boston University, pointed out via email that the paper raises a fair question about how the ages of supernova progenitors change over cosmic time, adding that it is always important to challenge our way of thinking in order to a better understanding of the universe. However, the way they model that evolution is not supported by observations nor by our understanding of how these systems form. Modern supernova analyses already account for the connection between brightness and the environments where these stars originate, which captures most of the effect they discuss. Extraordinary claims require extraordinary evidence, Dragan Hutero, a professor of physics at the University of Michigan in Ann Arbor, Miss Imigandink, said in an email that the new research does not rise to the threshold to overturn the currently favored model. Lee is aware that the work might be controversial. We have a long way to go to convince everyone in the supernova cosmology community. There are still many people who are strongly against our results, so a lot of debate and discussion should happen in the near future. However, he added, more clarity on the issue might be around the corner. The new Vera Rubin Observatory, which started operating this year, is set to help settle the debate with the early 2026 launch of the Legacy Survey of Space and Time, an ultra-wide and ultra-high-definition time-lapse record of the universe, made by scanning the entire sky every few nights over 10 years to capture a compilation of asteroids and comets, exploding stars, and distant galaxies as they change. Vera Rubin will discover more than 20,000 new supernova galaxies with very high precision age measurement. It will take 3 or 5 years, and it will allow a more direct cosmological test without worrying about this age bias effect. Dark energy is getting weirder and weirder, Lee concluded, but there is no good theory that can explain this very weird behavior. So, I think we are missing something. Maybe in 5 years, an even more surprising result can come up.